In this video, we are going to investigate the converse of the perpendicular bisector conjecture. In the last video, we started with what is the perpendicular bisector conjecture, and that is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. Well, now we're going to investigate the converse, meaning if we know that a point is equidistant or the same distance from two endpoints, will it be on the perpendicular bisector? And if so, then that will help us construct the perpendicular bisector. So what we're going to do is we're going to do this on the back of this page, but I'm just going to walk you through the different steps. So we're going to start with a segment, and what's going to happen is we are going to set our distance of our compass for more than halfway between the two endpoints. So if this is my segment, I want to set my compass distance more than halfway. Then we're going to do an arc strike from the one endpoint, and then we're actually going to flip and do an arc strike from the second endpoint. But actually, we have to do that above and below the segment. So what I normally do is make the arc strikes from above and below from both endpoints at the same time. Well, one at a time, but I do above, below, and then flip. So let's take a look at that. Here we go. Don't make your segment too small or too large. Again, I like to call this Goldilocks and the Three Bears because we don't want to make something so big that we can't fit it on our paper, but we don't want to make it so small that it's just difficult to work with. And it doesn't have to be horizontal. And in fact, I'm going to draw something diagonal just for that purpose. But you can certainly make something horizontal. So like we said, we are going to open our compass, put our stylus on one of the endpoints, and make sure your compass is open to over halfway. We're going to make a swoop above the segment and a swoop below. And remember, any point on these arc strikes is this distance away from the endpoint. Now we're going to go over here and do the same thing. Notice again, I did not change the setting on my compass. So this point is also the same distance. Think about when we constructed an equilateral triangle. It's the same sort of idea, except we're not actually equal to the distance of the segment itself. So I swoop above and below. So now I have two intersection points, and what we are going to do is we are going to construct a line here going through these two endpoints. So the question is this line on the perpendicular bisector of the segment? Use the paper folding technique of investigation 1 to check, which we could do, but actually I'm going to encourage us to use our protractor. I'm going to put this down so that I can not run into my top of my clipboard here. Yep, this looks like this is 90 degrees. I like that. Is it in the middle of the segment? Well, my segment is 775 centimeters. And so if I measure this distance, this is 35, 6, 7, 8. And this is also 38. There we go. So yes, this segment is the perpendicular bisector. So what that means is the converse of the perpendicular bisector is true. And this is a biconditional statement then. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. This conjecture is really important for a lot of different types of constructions, which we're going to talk about in a second. So first of all, why do we need to set the compass so that it's more than half the distance? Well, it has to intersect. So the points have to intersect. And again, if we're on the perpendicular bisector, it has to be meeting halfway. And if we're under halfway, so if I came up here and I only set my compass this far and I made a swoop, I wouldn't get anything intersecting on the other side. And then how does this help us find the midpoint of a segment? Well, actually, it tells us the mid segment, where the perpendicular bisector intersects the segment is the midpoint. This becomes really important for other constructions that we are going to do. And if you took a look at the vocabulary from this particular lesson, that is what's going to happen. So that's how we're going to construct the things that I'm asking you to construct, because you need to find a midpoint. Let's go ahead and do some of the examples associated with this lesson. Okay, so first we're going to draw triangle ABC, and we are going to construct the median from angle B to segment AC. So just a quick review on what a median is. If we have a triangle, and let's suppose this is our angle B, and here's ABC, a median connects the vertex of a triangle to the midpoint of the opposite side. So assume this is the midpoint of the opposite side. I would connect that. That's what our median is. So we can draw any sort of triangle we want. Let's make an obtuse triangle. That sounds kind of fun. Just to give something a little different. It doesn't really matter, again, who you're labeling A, B, and C. I'm going to make my top vertex B. So we'll make this A, this B, and this C. So I'm going to construct the median from angle B to AC. Well, that means I need to find the midpoint of segment AC. So how do I do that? Perpendicular bisector, swoop, 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 swoop. It's sort of my shorthand. Set my compass over half the distance. Swoop above, below. Don't reset the compass. Go to the next vertex or the endpoint of the segment. Swoop above, swoop below. Now again, if I connected this fully, that would give me the perpendicular bisector. For my purposes though, I just really want to mark the midpoint. And so I'm just going to go ahead and do that. Again, because I'm doing a construction and I want to make sure everything is thorough, I'm going to mark this with tick marks to show that this is a midpoint. And then my median connects my vertex B to there. So that's our median. Here is another fun construction. Construct triangle RGT so that we have a right angle. Well, now we know how to get right angles. We're going to take our straight edge, and I'm going to make a segment. And because I want to get a right angle, I don't want to make this segment too long, but I might come back and lengthen it a little bit. And I want a right angle. So I'm going to do my perpendicular bisector technique on this segment here. Oops. I didn't like that. Try again. There it is. Now, because I'm making a right triangle, I am lining up my straight edge so it hits both of these intersection points. Remember, this is my perpendicular bisector, but I'm actually just going to go above. It's not that I can't include, the bottom part of the segment, but I don't need it. So this is my right angle, which I am then going to label as angle R. And my other two vertices are somewhere else. I don't have any other restrictions on this triangle. It doesn't say to make it isosceles. It doesn't say that a certain segment has to be a certain length. So if I want, I can be done. And I can just go ahead, label this either G or T, and then finish off my labeling. For our last one, we want to construct a segment that has length 5/4 the length of segment AB. You can again do this a couple different ways. Because 5/4 as a mixed number is 1 and 1/4. What this means is we need to find 1/4 of this segment, and we can either copy that 5 different times, or we can go ahead and copy it 1 full time and then just that extra fourth. So it doesn't really matter. So how do we get 1/4 of a segment? Great question. Well, you do the perpendicular bisector technique twice. So start here. I'm going to adjust my pencil a little bit. Swoop, swoop. Now, if you notice, it looks like I didn't quite have enough of an arc strike from vertex A, so I can just go back and redo that again if I feel more comfortable understanding that or getting that to be a little bit more clear. I'm going to go ahead and mark this off. So this is our midpoint. So now I'm going to do my perpendicular bisector again, using A again as a midpoint, and then using the midpoint, A as an endpoint, and then using the midpoint I just found as the other endpoint. And there we have it, this little piece here. This is 1/4 of AB. To get my segment that has length 5/4, now we're doing some segment copying. I'm going to go ahead and draw a ray, label my endpoint. I'm just going to go for copying 5 of these. Actually, I feel like that might be a little bit easier. But you can copy 1 of AB and then an additional 4th. So that looks pretty accurate. I could have maybe adjusted that if I wanted. And now again, we've done this before where we make our swoopy marks and then we pick up our compass and then pick up where we left off on that next one. So this segment here has length 5/4 AB. There's lots of other constructions that we can do with finding, using that perpendicular bisector technique. And again, we will use this as we continue to move about this course. Great job in this lesson.